Hello, I'm Wiz, and this is Pip. And this series is Applied Probability for 5e, or TTRPGs. Our goal here is to bridge the gap between the math rocks and their outcomes. The series is meant to be as accessible as possible, and you should be able to follow if you know even a little bit about algebra. Each video is designed so that you can take a lesson and go apply it to your game right away. That's the applied part. The goal is to demystify probability and increase everyone's understanding and intuition by using one of our favorite games, emphasis on games. Even if you know all this stuff, I encourage you to stay around and contribute to the conversation in the comments. Especially if you are a GM or home brewer, a bit of probability goes a long way. Now first, what is probability? It's simply how likely something is to happen, and it is always represented as a number between 0 and 1. And we wish to express the likelihood of an event, we write it like this, and read it as the probability of event A. Now event A is just a placeholder. It can be anything you want it to be. It can be A, B, C, D, and it could represent anything. How likely you are to run out of gas within the next 30 miles, or how likely it is to rain. But generally, you would write a random variable as capital X. In this case, capital X, for us, would be the result of a die roll. And say we want to know the likelihood of rolling a certain result on our die, we would write it like this, and say the little x is the result of the die roll. And we would read this as the probability the result of the die is equal to the desired result. Now, to determine the probability of rolling a specific result on a single die roll, we would divide the number of desired outcomes by the number of possible outcomes. So in our case, for a die roll, if we want to know a specific number comes up, we would set the numerator equal to 1 and the denominator equal to the number of sides of our die, where x is the desired result and n is the number of sides of our die. For example, what are the odds we roll a 20 on our d20? We would write it as follows. The probability of x equals 20 is equal to 1 over 20, which will simplify to 5%. Now, we can take our formula, more properly formalize it, showing that the probability of a random variable capital X is equal to little x is shown by 1 over n on the range of 1 to n. And with this, we have a probability mass function, or PMF. A PMF is a function that gives the probability that a discrete random variable is equal to some value. In our case, our PMF gives the probability that a die roll of an n-sided die will equal any one result. And remember, because we used n in our formulas, this is generalizable to any sided dice. Now, let's plot the PMF for a d20. This will result in what is known as a uniform distribution, because each result is equally likely, so it is flat and uniform, hence the name. However, when playing TTRPGs, success often means rolling at least a target number or above. To express this, we can solve for the cumulative distribution function, or CDF, which calculates the probability that a given result will be equal to or lower. This is done by adding the probability of each result piecewise, like 1 over 20 plus 1 over 20 plus 1 over 20, until you get to the result you need. To represent this, we can write the following, which can simplify to the sum of all 1 over n terms over the range given by our target number. The probability that random variable capital X is equal to or lower than the result x is the sum of all the 1 over n terms from 1 to our goal number. Simplifying further, and we have in our right term the target number, divided by the number of sides n. Now that we have our cumulative distribution function, remember that this shows the likelihood of getting the target number or lower, but we are interested in the likelihood of getting a target number or higher. To achieve this, we would swap the left term to say the probability that capital X is greater than little x, and set that equal to 1 minus our CDF. Now, it is important to pay attention to the left term here and what we are saying. We're saying that the probability the random roll is greater than a target roll x is 1 minus the target roll over the number of sides. For example, say we need to roll above a 14 on our d20 to hit an enemy with attack. So the probability that a random variable x will be above 14 is equal to 1 minus 14 over 20, which simplifies to 30%. To visualize this, we can plot the CDF. would look like this. Remember, this is showing the odds of rolling the result, or lower, but we can simply subtract 1 and get a more useful graph for our needs. This showing the odds of rolling the result, or above. You can see simply flipped from the previous. And that has been Lesson 1 in Applied Probability for TTRPGs. I hope you liked it, and I hope it helped. There's extra material in the doobly-doo to help hammer down the concepts. Please direct any questions to the comments section. Also, any feedback can go down there. This is my first video on this channel, so I am open to any and all constructive criticism. Future videos will cover more probability distribution of dice, advantage and disadvantage, and even the damage per round formula. Any other suggestions or requests are also welcome in the comments. I'm Wiz, and this is Pip, and we have been Legend Lore. Thank you for joining us, and we hope you have a swell day.